Hi guys, and welcome to another quick physics minute. Today we're going to talk about the ideas of resonance and standing waves. Resonance is when we send a frequency through a substance or material which matches its natural frequency and we can increase the amplitude. What we're trying to say with that is if we go ahead and send some type of vibration in a system like this or like this, we may get different increases in amplitude based upon frequencies which want to go ahead and wiggle at that rate. So if I have these two bottles in this case, notice this one has a lot of air, this one only a little bit. We get a very low pitch. That uses the idea of the equation we have up top. V is equal to F lambda. V is the velocity of the wave, F is the frequency, and lambda is the wavelength itself. Both those two bottles, the speed of the wave is staying the same, but the wavelength is changing. They're dealing oftentimes with different systems with tubes, or we can see it like this as simple strings. Here I have a little box with a couple of strings attached here. If I hit any one of these, they produce different frequencies based upon how they want to wiggle. Now in this case, this part is held motionless as well as this is. This can be seen something like a closed tube. The strings of a guitar are also done the same way. Ultimately, if I plug a string, it's moving here in the middle and acts with nodes or the motionless points at either ends, an antinode, the part with that increase and decrease in amplitude in the middle. We can have multiple frequencies which basically get this increase in amplitude. In a closed system, we get what's called the first fundamental, or the first harmonic, when it's a double closed, and that length is half the wavelength. We get the second when it's one full wavelength. We get the third when it's 1.5 or 3/2 wavelengths. You get the same thing, it's a double open situation. You can think about that as a pipe with sound being sent through it like this. We get an increase in amplitude at specific frequencies based on what's going on. Again, half the wavelength if the length is one full wavelength, or if it's 3.5 wavelengths. The other way to look at this is if we have a partially closed system. That is something similar to what we see here. That, yes, I'm able to go and produce sounds and it exits, but it hits a boundary on the other side and reflects back. So down at the bottom part is a node, a place where it gets reflected back. So to have an increase in that amplitude as a resonant frequency, we have the first one when that length here is 1/4 of the wavelength of that wave. We get our second one at 3/4 of that, or we find it in terms of 5/4 of the original. This is something you want to try to remember, particularly in the ideas of these types of waves. The idea is that these work in multiples of 1/2, these in multiples of 1/4. Thanks, have a great day, and see you in the next video.